Well, part of factoring, a big part of factoring is recognizing trinomial squares. First of all, what's a trinomial? It has three terms. A squared is one term, 10a is another term, and 25 is the third term. Different than difference of squares. Difference of squares only had two terms. A squared minus 4, two terms. A squared minus 25, those were only two terms. Now in this case, you also have to have a positive out here for this to work. What happens when this works is you have to have a perfect square in the third term, a perfect square in the first term, and your middle term has to be follow a certain pattern. And the pattern is as follows. You divide your middle term by 2. So 10 divided by 2 is 5. And you square it, you get your third term. Simple as that. Does it work? Well, it does. Watch. 10 divided by 2 is equal to 5. And 5 squared equals 25. There it is. And that's your third term. Now, what is our answer? Go ahead with the brackets, Kiwana. Our answer to this one is a plus 5 and a plus 5. A plus 5, a plus 5. And if you FOIL it, you'll see it works. Because a times a is a squared, a times 5 is 5a, then another 5a, you get 10a, 5 times 5 is 25. Go ahead and do that just for the folks at home. You'll be getting, yeah, a times a is a squared, then you get a times 5 is 5a, and then another 5a plus 25. So those are always good to check. If you use the FOIL method, you'll be able to check your answers and you'll understand the inner workings of how factoring works. So there you go. A squared plus 10a plus 25. Now, I'm going to, while Kiwana's finishing that, I'm going to check this one out. Look at this one. Is that a trinomial square? Sometimes they just ask you, is it a trinomial square? Well, the answer is no, and here's why. Because even though this is a perfect square, 9, right? And that, when you cut 6 in half, you get 6 divided by 2 is 3. 3 times 3 is 9. That works, but didn't quite work out. Why not? Because this is negative 9. It won't work no matter what you try. You're tempted to write x minus 3 and x minus 3. The problem is you'll get x squared minus 3x and minus 3x, which is good. But you'll get plus 9 because the minus 3 times minus 3 is going to be positive. With trinomial squares, you can't have a negative here because trinomial squares always have to have a positive out here. So this is not a trinomial square, whereas this is one, and this is how the pattern works. Here's an interesting factoring question that you may have difficulties with unless you are following the steps. First of all, neither of these are perfect squares, so there's nothing we can do with that. But even if they were, the first thing we should always look for in every factoring question is taking the greatest common factor out. And if you think that way, you'll clearly recognize that 10 comes out of all of these terms. And when I say come out, it means that basically you divide 10 into each term. Right? Just like that. Now, when you divide it out, it comes out here. Put a big bracket, and you get left over t squared minus 2t plus 1. Is that the end of the story? No way. At least we don't think so. Why not? Because this factors. This is actually a trinomial square. That's a perfect square. That's a perfect square. Half of 1 squared equals 1. Or half of 2 squared equals 1, right? If you take 2, you divide it by 2 equals 1, and 1 squared equals 1, which is what we need. So we've got 10 on the outside, and we've got t minus 1 and t minus 1. If you FOIL that out, you'll see that it works. It involves looking for the common factor first, and then it involves looking then for either difference of squares or trinomial squares or factoring it in any possible way you can, and then getting your answer and putting it in this form. We're moving now to skills practice 16, the other side of the piece of paper. And these kind of questions are trinomials, but they don't have a perfect square. So they have to be factored a little bit differently. What you need to do for these ones is find the factors of this third term that, in this case, add to be the middle term. And if this is an addition sign, they add. If this is a subtraction sign, then these factors have to subtract to be that. First thing is to list the factors. So the factors of 14 are 14 and 1, 7 and 2, and that's it. Now, do any of those add to be 9? 14 and 1 don't, because that's 15. 7 plus 2 does, so we're in good shape with that. Plus 7 and plus 2 equals 9. And we can write that in now because we have our two factors. They add to be the middle term, and we simply put it in the format with the two brackets. We've got x and x because x times x is x squared. We have plus 2 and plus 7. And if we FOIL that out to check, we've got x times x is x squared, plus 7x plus 2x plus 14. X squared plus 7x plus 2x plus 14. And that indeed does check out because x squared plus 9x plus 14 does end up working out. So that's pretty straightforward. We're going to go to another question here. That was number 1 on your sheet. This is number 10. Number 10, n squared plus 12n plus 35. The only difference here is that we have a negative sign here. We still have a positive sign there. This is not a perfect square. There's nothing we can't take any common factors out. We always look for those two. Factors of 35 are 35 and 1, 7 and 5, and that's it. And do any of them add to be 12? They do. In fact, 7 and 5 add to be 12. But now, what about that negative? Well, we actually want negative 12. So how do 7 and 5 combine to be negative 12? Negative 7 and negative 5. It works perfectly. Negative 7, negative 5 equals negative 12. And we put our brackets up here. We've got n and n, minus 7, minus 5. And if we FOIL that out, you're going to get n squared minus 7n minus 5n and plus 35. Notice that there are two negatives here, n minus 7 and n minus 5. A negative times a negative gives you our 35, and when you add two negatives, you get your middle term, n squared minus 12n plus 35. So the other kind of example that we have involves having a negative in the third term. So now we have a positive here and a negative there. So what we're going to be looking for now is the factors of 5, the factors of the third term that subtract to be 4. The factors of 5 subtract to be 4. Let's list out the factors. There are only two of them, 5 and 1. And they indeed do subtract to be 4. 5 minus 1 equals 4. That makes it really easy. We've got a plus 5 and a minus 1. And again, it FOILs out a squared minus 1a plus 5a and minus 5. FOILs out and it works. We get a squared plus 4a minus 5. This right here checks out.